Good afternoon, this is Schweitzer. I'm going to run a little answer key to a video here on Introduction to Completion and Equilibrium. Alright, so this particular worksheet is, I think, easier to do via a little video than to the PDF, so let's give it a try. Alright, so reaction goes to 20% to completion. Alright, so we have x goes to y plus 2z, initial stoichiometric ratio n. I have 0.5 of this, and we're going to lose 20%, so 0.5 times 0.2 is 0.1, and that's minus 0.1 plus 0.1 plus 0.2, 0.4, 0.1, and 0.2. So good ice table work. Let's draw this out. So starting, this would be my initial stuff. This is my ending stuff. So initially I have all 0.5 of x, none of the y, and none of the z. Alright, so at the end you can just say, well, where is everything? This is what we want here. I got 0.4, 0.2, and 0.1, let's say. This would be the y, this would be the z, and this would be the x. And then you just connect your lines up. That was the y, that's the z, and that's the x. Of course, these would continue flat from this point, and this is the point where equilibrium is established. Alright, the next one. The same type situation here. Different chemical reaction, 0.5 of both of these guys. Alright, so pause it out, write it out, see what you got. So we got, give it a try here. If you got it done, let's give it a try here. So we have, spread ice table out. So I have A plus 2B yields 2C. Initial stoichiometric ratio N. I got 0.5 of this, and I got 0.5 of this, and none of this. What's the expression? Okay, so it's Kc equals concentration of C squared over the concentration of A, concentration of B squared. Okay, so let's take a moment to fill the ice table out. In order to get a Kc value, anytime you get Kc value, you need to populate and fill out the expression. So it's going to be minus, saying that the A goes 20%, so minus 0.1, minus 0.2, plus 0.2, that's going to be 0.4, 0.3, and 0.2. Alright, let's just plug it in. I got C equals 0.2 squared, I got 0.4 is A, and I have 0.3 is B, so 0.3 is going to get squared. And you can go ahead and calculate that value out here. Alright, so 0.2 squared divided by 0.4 divided by 0.3 squared is 1.11. 1.11. Let's draw it out here. So in that case, again, we have A is 0.5. And then it's A, and then you just have to mark it out. A is going to be 0.4, B is going to be 0.3, and then C is going to be 0.2. So they both start here. So this one's going to, you'll see the variation in the slope, which is good. This is your 2-3 ratio, and this is your 1. So technically the A and the C should have, it's like reciprocal slopes, similar. Okay, so keep moving here. Alright, so we have a reaction here and ends up like this. Let's draw it out. Alright, so I'm going to draw this. Keep in mind that we have only the ending values here. So all I know is that R and P both end at the same time, at the same concentration, R and P. Where they start makes no difference. I could start at the bottom with no P and end like this. Or I could start with, a little different concentrations. I could start with, this is R, this is P. I could start with lots. It doesn't matter where I start. I just have to follow the stoichiometric ratio of 1 to 1, because that's what I have here. So this guy is going to go here. This guy could go here. We could R and P could be. This could be R. Or this could be P. This could be P. R. This could be P. It doesn't matter as long as we end the same spot and we follow the stoichiometric ratio. Alright, so in this case here, we're ending at the reactant favorite. So I just want, if this is the reaction I'm using, then I need to have more R in the end than I do P. R and P. Again, where I start doesn't really matter, but I got to follow the stoichiometric ratio of 1 to 1. So I could have P, start, and call this Q, by the way. So if I could start, let's say, here, alright, lots of that way, then I have all, it'd be something, well, it would be difficult at this point. Let's see here, I'm going to be losing P and gaining, I need to, let's see, well, lots of P is showing this way. So I would come down here, and I would gain that way. I guess that's what we would do. There we go, and there we go. If I want to do it where I have a different starting point, let's say I'm over here, okay, then I have, let's get a little smaller down here. So now, same ending, okay, but I have all R. So this would be a little bit more difficult to do. I would need my R level to be like right here to start with, and then I would gain some, well, I have to lose R to get that way, so I have lots of R. Let's put that up here. There we go. Alright, so I would have to lose some R here to get to this point, and then I would have to gain some P that way. There we go. So there's a few different options. Just make sure we lose and gain at the rate of 1. Same thing is going to go here. Again, I just want more P in this end point than I do R. And here would be an option where if I start with right here, let's say I start Q right here, that means they're both in the middle, equal. Alright, and we gain here and lose here. Here, let's reverse this around where we're given the concentrations and we use this little dial here. Again, Q is where we're starting and P is where we're ending. So lots A is my, I'm going to draw A to and from B is what I'm going to go with. You could also do B to and from A. It does not matter. But in the end, A is the most. So we're going to have this being A, while this being B. And I'm going to end up with, start with a bunch of A. So this would be like my Q. And then at the end, I would end up with more A. So this would be like my K. Again, keep in mind that this particular drawing here is me. Like, I made that up. No one else uses it, so you really can't use that as a justification. But it's like a dial. If we did this one on here, I'll do that one in a different color. You would do it where we just start with different reactions. So now we would start like same thing. Start with lots of A. Let's just redraw it. Alright, so this is now going to be B, and this is going to be A. Again, if in this situation, I still have lots of A. That's my Q. I'm still going to end with lots of A. It'll just be there. Okay. That's it. Thank you very much.